Welcome to the deep dive. We are so glad you're joining us today.
Great to be here.
Today we're doing a deep dive into a source called Navigating the Edge, optimizing IoT solutions for every layer of your organization.
Yeah, and this is it's a really crucial topic right now, isn't it? The whole Internet of Things,
Yeah.
IoT. It's just exploding.
Exploding is right. It's not just growing, it's getting incredibly complex.
Exactly. And as that complexity, ramps up, figuring out how to actually build and manage these solutions so they work well and, crucially, deliver real value across the whole business. That's the big challenge.
Absolutely. So this deep dive is really aimed at you, whether you're, hands-on writing code as a developer, or maybe you're in technical management making those strategic calls. Our mission today is pretty straightforward. We want to pull out the most important, most useful insights, the real gems from this source material. The goal is really to help you understand how you can boost device functionality, but also how you make sure these IoT projects actually contribute to, well, profitability and productivity, the bottom line.
And we're going to journey through the core ideas in the material. So that means looking at how IoT even got started, its evolution.
Right, the history bit.
Yeah, and then really digging into edge computing, which is becoming so vital, plus tackling the massive job of managing all these devices.
Device management, yeah, huge.
And how the network and the applications interact, looking at sort of the fundamental principles, but also what's trending right now in the field.
So as we walk through this source together, it might be helpful for you, the listener, to kind of keep your own experiences with IoT challenges in the back of your mind.
Good idea.
What are the biggest headaches you're dealing with? Or where do you see opportunities maybe being missed because things aren't quite optimized? Thinking about that as we go could really help connect these ideas to your world.
Definitely. Okay, so where do we start?
Let's jump in.
Okay, let's kick off with that journey, the evolution piece. The source starts there, setting the scene, talking about how IoT itself has changed over time. It wasn't like an overnight thing.
No, definitely not. It highlights that shift from, pretty simple, often separate connected devices, think maybe basic industrial monitors or sensors.
Right, SCADA systems, things like that.
Exactly. To now, where we have these huge interconnected networks, sophisticated sensors everywhere, edge processors doing local AI, actuators controlling things, all talking to each other.
And the source really digs into what drove that change. It wasn't just one thing, was it? It was a whole bunch of tech advancements coming together.
Yeah, making things more complex, more interconnected.
Devices got, smaller, cheaper, way more powerful. That meant intelligence could actually move out closer to the things themselves.
And sensors, too. Just more of them, better accuracy, measuring all sorts of new stuff. A massive driver, and the source really points this out, was the huge leap in connectivity. Think about how wireless tech has evolved. Early IoT might have used, limited range radio or even wired connections.
Then you get faster Wi-Fi, you get cellular, 3G, 4G, now 5G, with its low latency and high bandwidth.
And critically, those low-power wide area networks, LPWANs, they were kind of game-changing for IoT, weren't they?
Absolutely. Designed specifically for this.
Yeah.
Allowing, millions of simple battery-powered devices to just send little bits of data really efficiently over long distances.
That better connectivity just changed the whole equation. Suddenly, you could connect vastly more devices in more places, sending more data more reliably.
Yeah, the economics just started to make sense for way more applications.
And working alongside connectivity was the progress in data processing.
Right, because early on, everything had to go back to a central server, didn't it?
Yeah.
All the raw data.
Exactly, for any analysis, any action. But the source highlights how that started to shift. As chips got more powerful and more energy efficient, doing significant processing near the source right at the edge became feasible, practical even.
And that shift, combined with, the power of the cloud for the really big analytics jobs, that's what really blew open the doors for what IoT could do.
Totally. The source makes the point that these advancements are why IoT moved from being, a niche thing in heavy industry.
Right, specialized uses.
To something you see everywhere. Smart factories, precision farming, remote health monitoring, logistics, smart cities. It just became scalable and affordable enough for everyone to start using it.
And looking forward, the source sort of hints that this evolution isn't slowing down. It implies trends towards even more autonomy for devices.
Meaning less reliance on the cloud for every little thing.
Yeah, exactly. And just more sensing capabilities everywhere, kind of woven into the background. Plus, deeper integration with AI and machine learning, which I know we'll get into later.
Okay, so this whole evolution towards smarter, more distributed systems, it leads us straight into this key idea of processing data closer to where it happens.
Which is the perfect setup for edge computing. We hear that term all the time.
All the time. So let's unpack it. What does it mean in the IoT context?
Right. So in IoT, edge computing is basically about shifting data processing, analysis, sometimes even decision-making, away from those big centralized cloud data centers and moving it closer to where the data is actually generated, right at the edge of the network.
And that edge could be the device itself,
Right.
or maybe a local gateway.
Exactly. Could be the sensor, could be a gateway box in the factory, could be a small server nearby. It's about locality.
Okay, so why is this such a big deal for IoT? The source lays out some pretty significant benefits. The first one, maybe the most obvious, is latency.
Oh, absolutely. Speed. When you process data locally, the delay between something happening and the system reacting is slashed. Milliseconds, often.
And that's absolutely critical for anything needing a real-time response.
Think about industrial robots on a production line.
Yeah.
Or self-driving cars, or even AR/VR systems.
Yeah, you can't wait for a round trip to the cloud for those.
No way. That delay makes those applications impossible. Edge processing just cuts it out.
Another huge benefit, less strain on the network, bandwidth savings.
Definitely. IoT devices, especially things like cameras or sensors firing off readings constantly, they can generate tons of raw data.
Right.
Sending all of that up to the cloud all the time. It's expensive, and it can clog up your network.
So Edge lets you process it first, filter it.
Exactly. You do that initial crunching, maybe aggregation or spotting anomalies locally.
Yeah.
Then you only send the important stuff, summaries, alerts, outliers up to the cloud. Cuts data transmission way down.
Makes sense. And reliability gets a boost too.
Significantly.
Yeah.
If that connection to the main cloud goes down, or even just gets patchy.
Which happens, especially in remote locations.
Right. Edge devices or gateways can often keep running on their own, using their local processing. That's vital for anything mission critical where you just can't afford downtime. Think remote pipelines, public safety systems.
Yeah, good point. And then there are the privacy and security angles, which seem more important every day.
Increasingly so. Processing sensitive data locally at the edge means it doesn't have to travel over public networks or sit in a shared cloud environment somewhere far away.
So that potentially reduces the risk of exposure?
It can, yeah. And it can make it easier to comply with data localization rules like GDPR or ETA, depending on what data you're handling. Keeping sensitive info closer to home gives you more control.
The source really drives home why these benefits are just essential for certain types of IoT applications.
Totally. You mentioned healthcare monitoring. You need those real-time alerts. Or smart city stuff, managing traffic lights or the power grid.
Immediate reactions are key there.
Exactly. For those, Edge isn't just a nice-to-have optimization. It actually enables applications that simply wouldn't work with a purely cloud-based approach.
Okay, but the source is also clear that edge computing doesn't mean ditching the cloud entirely, right?
Not at all. It's very much about a strategic partnership, a hybrid model.
So the cloud still has a big role to play.
Oh, absolutely essential. You still need the cloud for, long-term data storage, historical analysis, for building those massive data lakes.
And running analytics across data from all your devices globally.
Precisely. And training complex machine learning models that usually needs the cloud's horsepower. Plus, centralized device management, pushing software updates, orchestrating the whole system. The cloud is off of the control plane.
So deciding what runs where, edge versus cloud, it really comes down to the specific needs of the application.
Exactly. Does it need lightning-fast response? Edge? Does it need huge compute power for deep analysis? Cloud? Does it have to work offline? Edge? Need a central hub for everything. Cloud connectivity is vital. It's about finding that sweet spot, that optimal balance.
Does the source give examples of where edge really shines?
Yeah, it talks about scenarios like anomaly detection in manufacturing, spotting a vibration pattern that means a machine is about to fail, but stopping it immediately.
Before disaster strikes.
Right. Or doing video analytics on site, identifying a security breach without having to stream hours of footage off-premise first.
Makes sense. Or maybe processing data from hundreds of sensors on, say, a big mining truck locally.
Perfect example. You extract the key performance indicators, the alerts, maybe fuel efficiency numbers, and just send that summary data to the cloud, not the fire hose of raw sensor readings.
It's all about intelligent data distribution, but okay, whether processing happens at the edge or in the cloud, deploying solutions with maybe thousands, even millions of devices, that creates a whole new set of problems.
Oh, absolutely.
Oh.
Which takes us right into the next big topic, device management best practices. The source is very upfront about this. Managing that swarm of distributed IoT devices is seriously complex.
For everyone involved, right?
Yeah,
Developers building it, operations trying to keep it running.
definitely. You're dealing with devices that might be hard to reach physically, running on batteries, maybe connecting only intermittently, with wildly different capabilities.
Yeah, it's not like managing servers in a nice climate-controlled data center.
Not even close. So the source gets into effective strategies, starting right at the beginning, device onboarding and offboarding.
Getting new devices connected.
Yeah, and it has to be smooth, ideally automated, but above all, secure. How does that new device prove it's legitimate? How does it get its configuration, its initial software, without opening a security hole?
A clunky or insecure onboarding is a huge roadblock to scaling up.
Massive.
Uh,
And the flip side, offboarding, taking devices off the network, is just as vital, but often gets less attention.
what happens when a device breaks or gets replaced or just retired?
You need a clean, secure way to disconnect it. Revoke its credentials, make sure it can't try to reconnect later, or leave some kind of vulnerability open.
Yeah, you don't want ghost devices cluttering things up or becoming security risks.
Exactly. Bad offboarding creates clutter, wastes resources, and leaves potential attack vectors open.
Okay, so once they're onboarded, you need to keep tabs on them.
Continuously. The source stresses the need for tools for device monitoring and health checks. You need constant visibility. Is it online? Is it sending data? What's its battery level? Is the network connection okay? What software version is it running? Is it secure?
All that basic health information.
And being proactive is key. The source talks about health checks could be a simple heartbeat ping, could be reporting system stats like CPU load, checking sensor readings are within expected ranges, confirming data uploads worked.
So you can spot problems early.
Spot them before they cause real issues. A device stops reporting, or starts sending weird data, or its performance degrades. You want to know now, so you can fix it before you lose data or operations get disrupted? It prevents costly downtime.
And inevitably, this brings us back to security. It seems woven into everything with IoT.
It has to be. The source really underscores the critical security considerations in device management, because having all those distributed devices creates a much, much bigger attack surface than traditional IT systems.
Right. Why is securing every single device, even the seemingly simple ones, so crucial?
Because each one is a potential entry point, a weak link. An attacker compromises one little sensor or camera.
And they could potentially get into the wider network or use it for other attacks.
Exactly. Pivot to more valuable systems, steal data, or even pull that device into a botnet to launch attacks elsewhere. We've seen massive attacks launched from compromised IoT devices.
So what areas need focus for device security?
Well, the source implies the essentials. Strong authentication proving the device is what it claims to be. Robust encryption protecting data when it's sent and when it's stored on the device itself.
And updates. Patching.
Absolutely critical.
Yeah.
A secure, reliable way to push software updates and security patches remotely to potentially millions of devices out in the field. That's non-negotiable for long-term security and functionality. You have to be able to fix vulnerabilities.
Okay, so managing individual devices is complex enough. But it's not just about individual units, is it? It's about getting them to work together.
Which leads us straight into the next major challenge the source tackles. Interoperability in IoT is a huge issue.
Yeah, getting different devices and platforms to speak the same language.
Because the reality, as the source points out, is that most real-world IoT solutions are a mix and match. Hardware from vendor A, sensors from vendor B, connectivity modules from C, maybe a cloud platform from D, applications built by different teams.
There's no patchwork sometimes.
It often is. And getting all those different pieces to communicate and share data smoothly, that's a massive hurdle.
This is where standards come in, right?
Indeed.
Agreed upon rules.
Exactly. The source emphasizes the role of standards and protocols. Things like MQTT or COAP for messaging, designed to be lightweight for these constrained devices, or standard data formats so one system can understand the data coming from another. They're like the common languages enabling different components to talk.
And why are standards so vital?
Well, mainly to avoid getting locked into one vendor's ecosystem. If everyone uses standards, you can mix and match components, integrate things more easily, it lowers costs, and it just fosters a more open, competitive environment. Better for everyone, usually.
But even with standards, integration isn't always easy.
Still challenging. Not everyone adopts standards perfectly, or they might add their own proprietary twists. Plus, you've often got older legacy systems or really niche devices that just use their own unique way of talking.
So you end up having to build custom bridges.
Pretty much. You might need custom connectors or special middleware software that acts as a translator, or you build complex data transformation pipelines just to get System A to understand System B.
That sounds like it adds a lot of complexity and cost.
It does. As development time, ongoing maintenance headaches, imagine trying to connect different generations of factory machines or various types of environmental sensors. Each needs its own integration work without standards.
So how do APIs fit into this? The source mentions application programming interfaces.
Right. APIs are key here. They provide a standardized software interface for different applications or services to talk to each other, kind of hiding the messy details underneath.
So in IoT, an API lets my application talk to a device platform without needing to know the nitty-gritty of how that specific device communicates.
Exactly. The API offers a consistent way to, say, get sensor readings, send a command, or push data to another service. It abstracts away the underlying complexity, making integration much easier at a higher level, speeds things up, makes solutions more flexible.
So getting devices and systems talking is step one, because then they can actually collect and share data.
Which is the whole point, really, the lifeblood of IoT.
And that leads us neatly to how you manage all that data management strategies. The source frames this as a huge challenge. What do you do with the immense volume and variety of data IoT spits out?
Yeah, it's easy to underestimate. Even a moderate number of devices can generate a staggering amount of data. Sensor readings every second, images, logs. It adds up incredibly fast.
Yeah.
And it's often messy, unstructured data.
So where do you store it all? The source revisits the cloud versus edge and prem discussion here, specifically for storage.
Right. When do you need local or edge storage? Often for that real-time processing we talked about, where you need the data instantly. Or for strict privacy or security rules where sensitive data must stay within a certain physical location or network.
And the cloud is for it.
Typically for the long haul. Archiving historical data, building those huge data lakes for comprehensive analytics.
What's a data lake again, exactly?
Think of it as a massive storage repository where you dump vast amounts of raw data in its original format. Structured, unstructured, doesn't matter. You store it all and then figure out how to use it later with various analytics tools.
Got it. So cloud for scale, long-term storage, big analytics.
And making data accessible to different applications and users easily.
What factors influence that storage decision?
A bunch of things. How much data? How fast is it coming in? What are the security needs? And crucially, what do regulations say? Compliance often dictates where certain data must live.
But just storing data isn't the end game. The source really hammers on the importance of analytics and real-time processing.
Absolutely. Collecting data is useless if you don't get insights from it. That's where the value is unlocked.
So real-time processing is about immediate action.
Yeah, analyzing data as it streams in and triggering automated responses, alarms, control adjustments, rerouting things based on live conditions.
And analytics is more about looking back or predicting.
Often, yes. Processing historical or aggregated data to find patterns, trends, predicting when a machine might fail. That's predictive maintenance. Optimizing processes, getting business intelligence, making smarter strategic choices.
So turning raw data into actual useful information is where IoT really pays off for the business.
That's the core value proposition. It's the difference between just knowing a temperature is high and knowing why, predicting failure, and scheduling maintenance proactively. That saves downtime, saves money, directly impacts efficiency and how well you use your assets.
And handling all this data responsibly is critical. The source talks about data governance and privacy compliance.
Absolutely essential. You need clear rules and processes for how IoT data is collected, stored, who can access it, how it's used, and how it's eventually deleted or anonymized.
What does that involve? Things like data ownership.
Definitely. Who owns the data generated by devices?
Yeah.
Especially if they're on customer sites. Plus, strong access controls, who gets to see what. Data retention policies, how long do you keep it? And of course, ensuring you comply with all the relevant privacy laws like GDPR, HEA, CCPA, whatever applies.
And the risks if you get this wrong.
Severe.
Yeah.
Huge fines, loss of customer trust, which is incredibly hard to win back legal trouble. Given how much data IoT can generate and how personal or sensitive some of it can be, screwing up data governance can be catastrophic.
Okay, so managing the data effectively is key. Yeah. And that capability is also tied into whether the system can grow, right? Handle more data, more devices later on.
Precisely. Which brings us to another foundational principle the source covers. The importance of scalability. It's framed as a necessity. Your IoT solution has to be able to grow as your business grows.
You can't just build something for 100 devices and hope it works for 100,000.
Not without hitting major walls. Performance tanks, systems crash. Planning for scale needs to be baked in from the very beginning, not bolted on later.
So the source talks about designing scalable architectures. What does that involve? What principles?
It's about building systems that can handle more load gracefully, more devices, more data streams, more users hitting the platform, more complex analytics. Key principles include things like modularity.
Breaking it into independent pieces.
Exactly. So you can scale up just one part, maybe add more data processors or more connection handlers without rebuilding everything. Also, using distributed systems design, spreading the work across many machines instead of one bottleneck. And of course, smartly using both edge and cloud resources to balance the load.
The source probably uses case studies to show this, companies that scaled successfully.
Likely describes the types of scenarios. The company that went from a single factory pilot to a global rollout. Or the utility deploying smart meters citywide after starting in one neighborhood. That kind of massive expansion only works if the underlying architecture was designed for it.
But scaling isn't easy. The source must cover the challenges too.
Oh yeah, there are definite hurdles. Costs can skyrocket. More devices, more data means higher infrastructure bills, network costs. Just managing the complexity of a huge distributed system updates, monitoring, troubleshooting gets way harder.
And security across that massive footprint.
A constant challenge. Keeping thousands or millions of distributed devices secure requires robust, automated processes.
So the key takeaway is planning ahead.
Absolutely. The source likely argues that by choosing scalable technologies and platforms, designing flexible architectures, and having solid automated management tools from the start, you avoid painful and expensive re-architecting later. You build a solution that can evolve.
Okay, building something scalable, robust, secure, that takes serious investment, which brings us to justifying it.
Right. Chapter 7 in the source. Building the business case for IoT investments. This is where the technical side meets the financial side.
Translating tech benefits into dollars and cents.
Pretty much. Because implementing IoT isn't cheap. There's hardware, software licenses, development time, maybe network upgrades, deployment costs, and then ongoing operational costs, connectivity, cloud services, maintenance. You need a strong case to get funding.
The source talks about identifying specific ROI metrics. What kind of things should you measure?
Metrics that tie directly to business results. The source might list things like improved operational efficiency, maybe fewer manual steps, better resource use, reduced costs, predictive maintenance, cutting downtime and repair bills, maybe lower energy use, less waste.
Or even new revenue.
Yeah, maybe offering new data-driven services based on your connected products, or just using your assets better because you know where they are and how they're performing, or even improving customer experience, leading to more loyalty. Quantifiable benefits.
And it's important to look long-term, right? Not just the initial setup cost.
Definitely. The source emphasizes a long-term cost-benefit analysis. You need to project costs and benefits over the solution's lifespan, maybe 3, 5, 7 years.
Factoring in ongoing operational costs.
Exactly. Connectivity fees, cloud bills, software subscriptions, maintenance, support staff. And on the plus side, project the cumulative savings, new revenue potential, maybe softer benefits like better safety or compliance over that whole period. A long view is essential because many IoT benefits build up over time.
And then you have to sell this vision. The source covers engaging with stakeholders, getting the money people on board.
Which means speaking their language, translating tech talk. How do you explain low latency edge processing to the CFO?
You talk about preventing accidents and lowering insurance costs, or improving product quality and reducing scrap.
Precisely. You connect the tech feature to a tangible business outcome. Scalability isn't just a cool feature. It means the system can support future growth without a massive reinvestment, protecting the initial outlay. It's about linking technology to business value.
Okay, so getting the funding, deploying the tech, none of that happens in a vacuum. It requires teamwork.
Which is Chapter 8, Cross-Functional Collaboration. The source stresses how vital it is to break down those traditional organizational silos for IoT projects.
Because these projects touch so many different areas,
It's
right?
inherently cross-disciplinary. You need hardware people, embedded software folks, cloud developers, data scientists, network engineers, security experts, operations teams, and crucially, people who understand the actual business process you're trying to improve, manufacturing, logistics, whatever it is. No single team has all the pieces.
The source mentions breaking down silos and specifically brings up DevOps and IoT. Why is DevOps a good fit here?
Because in IoT, that line between development building the stuff and operations deploying and running it in the real world is super blurry. You're not just pushing code to servers. You might be updating firmware on remote devices with limited connectivity.
So DevOps helps bridge that gap.
Yeah, that culture of collaboration, automation, continuous integration and delivery, it helps bring those different skill sets together. Hardware, software, ops teams work together from the start, catching problems earlier, deploying more reliably, managing things more smoothly based on real-world feedback.
But collaboration requires good communication, especially between technical and non-technical folks. That's always a challenge.
A big one. How do engineers talk to business strategists or end users so everyone's on the same page about goals, progress, limitations?
What strategies help?
The source might suggest things like agreeing on common project language, focusing discussions on the desired outcomes, not just the tech details, using clear visuals or dashboards, and just having regular meetings where everyone involved talks openly.
Ultimately, the source seems to say that the culture matters a lot.
Profoundly. The impact of collaborative cultures is huge. You need shared goals, respect for different expertise, and a willingness to work through the inevitable, complex issues together.
Collaboration finds risks earlier, right? Different viewpoints.
Exactly. And it sparks innovation. Mixing hardware, software, data, and business knowledge often leads to way better, more creative solutions. Building those strong teams and processes is also key to making sure today's solutions stay relevant tomorrow. Which is a perfect segue to Chapter 9. Future-proofing your IoT solutions. How do you make sure your big investment today isn't obsolete in 3 years?
Yeah, in a field moving this fast, that's a real concern. Technology changes constantly.
New hardware pops up, software evolves, new communication standards emerge. The source says your solutions need built-in flexibility to adapt without a complete rip and replace.
How do you build in that flexibility, modularity again?
Modularity is key, yeah. Building with interchangeable components and using open standards whenever you can. That makes it easier to swap out parts later or integrate new tech from different vendors without being locked in.
It's not just tech changes, though. Regulations evolve, too.
Right. The source covers preparing for regulatory changes. We're seeing more rules around data privacy, cybersecurity for connected devices, certifications, even environmental impact.
So you need to stay informed and be ready to adapt.
You have to. Build systems where you can, say, easily audit data access or apply new security patches mandated by law. Flexibility is crucial for compliance down the road.
The source also brings in sustainability and ethical considerations as part of future-proofing. That feels increasingly important.
It really is. This goes beyond just tech and rules. Sustainability means thinking about the whole life cycle, reducing e-waste, designing for energy efficiency, especially with battery devices.
Can't fix.
That's about the societal impact. Issues like potential bias in AI using IoT data, worries about surveillance, being transparent about how automated decisions are made.
So thinking about the stuff up front makes solutions more resilient.
And more responsible, more trusted. It helps avoid backlash, builds user confidence, and aligns with broader corporate responsibility goals. It's smart business, not just good ethics.
Okay, so as we think about planning for this future, building these resilient, adaptable systems, what does that future actually look like? What's next?
That takes us to the final chapter, Visioning the Future of IoT. The source wraps up by looking at the crystal ball based on current trends.
And a big trend mentioned is obviously AI and machine learning integration.
Huge. We've touched on it, but the source sees it becoming even more deeply embedded, more AML running on the edge devices themselves.
For faster local decisions, more autonomy.
Exactly. Devices that can learn and adapt locally. And in the cloud, even more powerful AI for predictive analytics, finding complex patterns, maybe even automating system management itself.
How does that transform things, make systems proactive?
Yeah, instead of just reacting, they anticipate. Self-diagnosing problems, optimizing performance on the fly based on complex conditions, providing much deeper insights from the data.
The source also talks about us, the users, evolving consumer expectations.
Right. As we all get used to smart homes, wearables, connected cars, our expectations for all connected tech are rising.
We expect things to just work together seamlessly, be easy to use, secure.
Totally. Intuitive interfaces, strong security, and privacy are becoming table stakes.
Right.
And transparency. People want to know what data is being collected and how it's used. These demands shape consumer products, but they bleed over into industrial enterprise IoT too. Simplicity, reliability, privacy, key differentiators.
And finally, the source sums up IoT's role in digital transformation overall.
Yeah, it positions IoT not just as a technology, but as a fundamental pillar enabling that transformation across all industries.
Because it connects the physical and digital worlds.
Precisely. Sensors gather real-world data. Actuators let digital systems control physical things. Combine that with the scale of the cloud and the intelligence of AML, and IoT lets organizations see more, automate more, optimize better, create entirely new business models. It's truly transformative.
It really is an exciting, maybe slightly intimidating future.
Definitely both.
Well, we have certainly covered a lot of ground today, really digging into navigating the edge, optimizing IoT solutions. We've gone through the whole journey, the evolution of IoT.
Right, from simple beginnings.
The critical role of edge computing, the massive task of device management, making things interoperable, handling all that data.
Scalability, building the business case.
The need for collaboration, and finally, trying to future-proof these complex systems.
Yeah, it touches on pretty much every layer you need to consider.
And our goal really was to pull out those key insights that are useful, whether you're deep in the code or making strategic decisions, all focused on making IoT work better and deliver real value.
Hopefully this deep dive gave you, our listeners, some valuable perspectives, maybe sparked some ideas for your own work in this incredibly dynamic IoT space.
Definitely. So as we wrap up and we think about this future where IoT, AI, and our physical world are becoming ever more tightly linked, here's a final thought for you to chew on. Beyond all the technology challenges we've discussed, what do you think is the single biggest non-technical hurdle? Maybe ethical, maybe regulatory, maybe societal acceptance, maybe organizational change that we absolutely have to overcome to make sure IoT reaches its full potential safely and beneficially for everyone? Something to think about.